Good morning, everyone. We are here today to tell you the story about Truecaller, of how they use modern big data technologies to help decision-making and to shape their successful project. Let's start with introducing the main protagonist of today. Truecaller is a Swedish startup founded in 2009, and they are pretty successful. They were even chosen the hottest startup of the year around 3 years ago in Sweden. And in Sweden, the competition is really tough. There is a lot of very successful startups there that operate on global scale. And Truecaller currently has more than 250 million users. And this is the mobile app, by the way. And their business idea is quite brilliant in its simplicity. Truecaller is just a global phone book. So if someone calls me and I don't have this person in my contacts, but this person uses Truecaller or someone added this person to Truecaller database, then Truecaller application will show me the name of this person. I think it goes without saying that this is a pretty useful feature. Although, okay, someone may say that I can still answer the phone, learn who this person is, add this person to contact list, and later on when this person calls, I already know his name. But there is one more functionality of Truecaller that makes a real difference. Let me ask you a question. So who of you received spam or spam call or spam SMS yesterday? By spam call, I mean pesky telemarketer trying to sell you credit card, loan, new mobile plan, set of magic pods or something else that you don't need. So please raise your hand. Okay, what about last week? Whole last week? Yes, see like half of you. It happens that if you were in India, then statistically all of you would raise your hand as an answer to my first question. In India, on average, every person gets one spam call a day. And Truecaller has this functionality that allows automatically block spam calls. So Truecaller community, all of the users of this app, can mark certain numbers as spammers, and then such numbers can be just blocked, so you're not disturbed with this spam call. So no wonder that in India, Truecaller enjoys the greatest popularity. So it is I think, one of the most popular app. Some people even say that it is the single most important and useful app that they have on their smartphones. There are a couple of more features of Truecaller app, but I consider these two, namely identifying of unknown callers and being able to block spam calls and spam SMS as well as the features that drive the company's success. I learned about Truecaller in late 2014. This was the time when they hit the wall with their current IT systems. So the number of users were growing rapidly, and they simply couldn't handle the load. So the IT infrastructure prevented them of taking full advantage of the data. My name is Piotr Krewski, and well, I'm, as was said, co-founder of Getindata. And Getindata is a company that brings together administrators, architects, analysts that specialize in open source big data technologies. And in late 2014, Truecaller asked us to help them in the transition phase into modern big data architecture. And the first part of this presentation will be just about the landscape of big data architecture at Truecaller. And the second part delivered by Tomek. Tomek works as analyst in Getindata and currently helps Truecaller in their day-to-day analysis. So he will tell you how Truecaller actually uses all of the data that they can get a hold of. Let's look at some numbers. So every day there is more than 8 billion events generated by users who use Truecaller application. Truecaller is already at petabyte scale. Every day there is more than 3.5 terabytes of data being added to this system. There is almost 80 million of active users and close to 1 million new installations every day. And these numbers are only growing, so the rate of growth is only increasing. And there is, every day, there is 33 identified spam calls, which, well, if we assume that the average spam call takes less than 2 minutes, then 33 million calls would amount to almost 100 years of saved time for Truecaller users. Of course, if telemarketer is rejected by Truecaller, then he continues with the next person in the list, so overall he wastes other person's time. So better to be Truecaller user in this world, and I strongly recommend you to use the app. I'm a happy user since 2014. App is free. They monetize on showing ads, but they are not that annoying, so I strongly recommend to use it. It saves you some time and annoyances. I will now enumerate 7 sins of early Truecaller architecture. So the problems that they faced that prevented them to enjoy the growth and to be able to analyze the data. First sin is that basically for everything they used MySQL databases, which was probably a good choice at the beginning because they had to iterate really fast at the beginning, right? Ship new releases of the application, and a lot of people know MySQL, so it was easy for them to recruit people and so on. But later they fell victim of their own success. When the number of users started to grow, so the number of transactions that hit the database, number of SQL queries run against database, then it turned out that the MySQL instances were heavily overloaded. There were a lot of crashes, a lot of delays. So they actually couldn't continue with this kind of setup. They had to look for something totally different. The second sin of this architecture was that the production transactional database was not at all separated from OLAP domain. So all of the reports, all of the SQL queries calculating important metrics hit the same database as all of the production requests, what made the problem even worse. Third sin is that the ETL processes that they had to run became really, really slow with the growing size of the data. At some point of time, the daily ETL process took around 28 hours to complete. Well, so since they couldn't stretch the day beyond 24 hours, they had to obviously disable parts of the ETL processing. And it resulted in data being less accurate. The next thing is that they couldn't store all of the historical data sets. They were able only to keep 3 months of data in MySQL database, which, well, may not be the problem in day-to-day operations, but for startups like Truecaller, especially in their early stage, it's pretty, they just rely on external funding. So they need to convince investors to pour more millions to just keep going. So if they're unable to show the full trends over the past years of to illustrate what's the potential, to illustrate what's the market possibilities there, then, well, they can undermine their chances of raising more money. So this is pretty important to have access, being able to analyze all of the historical data. And they couldn't do it with their MySQL-based infrastructure. Next thing is that they were only able to run really simple aggregations and reports. So they knew how many active users they have, what is the total number of new registrations, but they couldn't actually do anything more complicated, like machine learning or some other advanced analytics. They just simply didn't have infrastructure that would allow them to do so. The sixth thing is that they didn't have any data warehouse design principles. Actually, they didn't have any design principles whatsoever regarding the schemas of the data. They wanted to iterate really quickly, what resulted in a lot of hacks in the data, a lot of different fields with meaning that was unknown. There was no documentation. So we had to do a lot of truly detective work to figure out what's the meaning of individual fields when we are moving all of the data sets from MySQL into Hadoop. And what stems from all of the already mentioned problems is that people simply didn't trust the data. They couldn't base their decisions on data because system was unreliable, there was a lot of events missing, so no one could be sure that they are looking at the real data. So one of the goals for the new infrastructure was to establish confidence in data, so they could make truly data-driven decisions. This picture illustrates the current landscape of big data architecture at Truecaller. We started with Hadoop cluster. So the goal was to put all of the Truecaller's data into HDFS, and then they had Yarn to being able to process and analyze this data. So this was the first thing that we did. So install and configure Hadoop cluster. Then we dumped a few data sets from MySQL just to quickly be able to build reports on the new infrastructure and show them that they can get a real value from introducing this new platform. But shortly after that, we started to take care of the full ingestion process. So all of the events from Truecaller users, they just first are shipped to the backend servers, and from there they are published to Kafka. And Kafka is this big data messaging system that is scalable, reliable, and so on. So it was the first place where all of the events landed, and then from there, events can be consumed by different systems. And the major consumer of the events from Kafka is Hadoop. And to ship data from Kafka to Hadoop, we had to use some tool. At the beginning, we used Apache Kami, which is a tool developed by LinkedIn. Recently, we switched to Goblin, which is the successor of Kami, also developed by LinkedIn. However, this is more general tool, so it's not only for sending events from Kafka to HDFS, but it's more general big data ingestion framework. So it can work with also with relational databases, with cloud file systems like S3 or Google file system. So when all of the data is already on Hadoop cluster, then we run a bunch of Spark applications and Hive queries to clean, transform, enrich, and aggregate the data. And to orchestrate everything on Hadoop cluster, to decide about the sequence of the applications, to be able to retry tasks that failed, we need to use some kind of orchestration and scheduling framework. At the beginning, it was Apache Uzi, which is, I guess, the most popular orchestration framework on Hadoop. It's bundled both in the Cloudera and Hortonworks distribution. So we started with this. We also used Apache Falcon, which is a layer on top of Uzi, which makes it a bit easier to define workflows. However, with time, we were not totally satisfied with this setup. There were problems with Falcon. There was a lot of half-done functionalities, and it was inconvenient to define workflows with Uzi, so we decided to change to something else, and we decided to use Apache Airflow, which is a tool created by Airbnb. This is also orchestration framework, but well, it does not only focus on Hadoop. It is like general purpose orchestration and scheduling framework. It is written in Python, so you define all of the dependencies in Python as well. It has really nice web interface that you can use to track all of the workflows. You can use it to visualize the workflow in many different ways, and you can also manage the workflows from there. It's definitely much more convenient than the tools that Uzi offers. And finally, when all of the data sets is already cleaned and transformed, it can be consumed by users. So users can use different tools to access the data on HDFS in Hive, but we'll tell more about them later on. So with this new big data architecture, they achieved scalability. So both ingestion layer and the storage and analytics layer scale horizontally. So if you need more storage or more processing power, either in Kafka or in Hadoop, we just add more nodes to the cluster and everything works just fine. There is high availability configured for both master and worker nodes, so there is no single point in failure, neither in Kafka nor in Hadoop. We use Apache Avro as the data format for events stored in Kafka. And one of the requirements from the beginning was to make it possible to evolve the schema, to add new types of events, to add new fields to existing events. And we had to do it in a smooth and automatic way. So we implemented the fully automated ingestion pipeline so that when there is a need for new event type, it just has to be published to the schema repository, and then everything down the line just works fine. So all of the ETL processes still work, nothing breaks, it is fully automated. And it was really needed because when we started to implement this ingestion pipeline, there was around 30 fields in the schema of the events, and in half a year there was already 60, and it's still growing. So thanks to the fact that the process is fully automated, we don't waste time for any manual work. Last thing is that we have clear separation on Hadoop side between raw data and the data that is used for reporting and processing. So the raw data is in Avro format, so this is a raw-oriented binary format, pretty popular in Hadoop. But it turns out that it's not really efficient when you want to query this data and process it. So these final data sets that are used by analysts are kept in ORC format, which is columnar format. It has two main benefits. First, it occupies less space on HDFS, and the second thing is that we can achieve much better performance when we query data stored in ORC. There is a lot of optimizations that make it more efficient than, for example, Avro. So after the initial infrastructure was in place, after we implemented first ETL processes and first reports, we did a couple of presentations of new architecture to Truecaller employees, so they know that there was a change in the systems, and now the system is reliable. They can really trust the data. So with time, they started to ask more and more questions. They asked analysts to prepare reports, like people from marketing, finance, owners, investors, and so on. And quickly it turned out that analysts were swamped with requests. And most of these requests were pretty simple, like people from marketing asking what's the number of active users in Brazil because they're running some marketing campaign or something like that. So this is pretty simple aggregation that these users could done themselves if they only know how to do it or know SQL. But it happens that many of users are not technical and they don't want to go and write SQL queries. So there was a need for self-service tool that would allow such users to learn themselves about the data and be able to do simple slice and dice analysis. And with self-service tool, it's pretty important to get good performance, to provide them this interactive experience when working with data. So when they group by another dimension or they apply additional filters, so it should recompute quickly. So to achieve good performance on this OLAP-like analysis on big data on Hadoop, we installed and configured Apache Kylin. And Kylin works with data stored on HDFS. It builds OLAP cubes. And it also provides nice UI that you can use to define the cubes, so all of the dimensions and all of the measures. And then it uses power of Hadoop cluster to build the cubes. So it can run either MapReduce jobs, or in the recent version of Kylin, it can also use Spark applications to build the cubes. And when the cubes are ready, they are sent to HBase for fast access. And the interface to Kylin is SQL. That is fully compatible with ANSI standard. And when you run the query in Kylin, then it takes advantage of the data that is stored in HBase, data that is already pre-aggregated, so you get your results really, really quickly. And since it's ANSI compliant, it can be integrated with BI tools. After a quick evaluation at Truecaller, they choose Tableau as their main BI and self-service tool. And with Tableau, you can basically work in two modes. So either maintain live connection with Kylin, so when business users change something on the graphs, on the report, then the SQL queries are generated and are sent down to Kylin. There is also other way you can work with extract, so you can run Spark application to pre-aggregate the data and send this extract, this already pre-aggregated data to Tableau server, and then business user can just work with this extract loaded into Tableau server without the need to go to the external systems. Okay, this is end of my part. Now I'm handing over to Tomek, who will tell you more about what they actually do with data.
Thanks. I would like to tell you about tools we are using as analysts in Truecaller and about tasks we are doing and what we can achieve with data which are prepared by data engineering team. We are using Tableau, as Piotr said. For me, from this set of tools, the most shocking one when I seen it for the first time was Hue. It is a Hadoop user experience abbreviation. It is a visual interface for Hadoop ecosystem. It lowers a lot entry barriers. It's even accessible for just analysts who know only SQL and are used to querying data in systems like SQL Server when you have normal user interface and can write your SQL query there. When we have data ready, we can use Jupyter Notebook to manipulate the data, to easily visualize it. Thanks to Jupyter Notebook, you can use a lot of different programming languages to manipulate your data. Originally, it was only Python. Then, as the name of Jupyter Notebook states for Julia, Python, R, it was these three languages. Now there are multiple other kernels available for Jupyter, so it's a very flexible tool. In Truecaller, we also use Apache Zeppelin notebooks. You can ask why we would like to have both on board, because they are, in theory, very similar in functionalities. But Apache Zeppelin is much easier, has much better integration with Hadoop ecosystem, with a lot of different data sources. You can use both Hive, Spark, or other parts of Hadoop ecosystem. The main part of our job connected with ETL process and transforming the data and preparation for reporting is done with Scala and Spark. Most of the tasks are coded there and orchestrated with Airflow, as Piotr said. And the last but not the least tool I would like to say is Microsoft Excel. A lot of people don't like it. A lot of people think it's not really an IT tool even, but I personally think it's still a king in a field of data analysis. You can easily share your findings, quickly see what you have in data. So it's a very good tool for the beginning. What we can do with such amount of data? Why we need to collect a lot of data? First thing is reporting. Management want to know what's going on with a company. What are the trends? Investors want to see what's going on. Also, product owners or even single developer from time to time needs to see how his functionality works. thanks to data, we can visualize a lot of different processes, a lot of different functionalities in application, how they work, how people use them, are they popular. Next thing is calculating user value. It's important to know how much you can earn on the user. In the end, the main goal of a company is always earning money. So it's good to have a knowledge how to calculate it. In theory, it's easy. Its lifetime is area under the retention curve, and you have to multiply it by revenue per user per time unit. In practice, I met a lot of situations where I was unable even to calculate retention properly because of lack of data or issues with user IDs which were reset in strange situations or were duplicated. Thanks to good data gathering system in Truecaller, it's not a problem. You can easily calculate such things. And for example, lifetime value. What more you can do if you have good data? You can do A/B testing during development of new functionalities. You can test different versions of an application to check which will be better for users, which one users will like more. But in case of such applications with such a number of users, in A/B test, there's one thing you have to remember. In case of testing on a very large scale, almost all differences will be statistically significant. I made this error in one of the previous companies I worked. We were finding a lot of statistically significant results, and we were reporting all of it to the management. But later we found out that this differences really doesn't matter because the effect size was so small that it was not important from a business perspective. Data also help in making data-driven decisions. We now receive a lot of questions from management, from developers, from product owners, from strategy team, what our users like in our app, what they do, what are steps, how does funnel looks like. Data-driven decisions, as they are based on evidence, usually are better than personal judgment, which can be biased. On the other hand, data are also sometimes biased. Have you ever had an experience with biased data or wrongly gathered data? Nobody raised his hand, but it's a rather usual problem that data is not clean. And I will show you later an example of such analysis made on biased data, where you can have wrong answers after this. Thanks to data, we can also test how a new functionalities works after releasing them to users. If the app after the release don't have a lot of crashes. It just helps in the release process to control if there are no problems in the new release. We can also better target ads. In general, I guess nobody likes ads, but they are everywhere now in the internet, in the mobile apps. Thanks to using data, they can be better and better. They are not just random. I know that there are a lot of ads like fridge haunting you for weeks after you accidentally searched for one in Google. But I believe that working on targeting ads will finally get rid of such situations, and the ads will be much better targeted, so they even can be helpful. We use our data also to detect fraudulent user behavior. In case of Truecaller, the most important fraudulent behavior is re-verification of a number. When the new user installs an app, he is getting SMS with a verification code, and then we know that he owns this number. Company has to pay for this SMS, and it's a normal process. But from time to time, we are finding users who are requesting thousands of such messages a day, what generates a cost for the company. What's interesting in this type of an attack, attacker doesn't have any revenue or benefit from it. It generates only losses for the company. And now the most important part of data analysis we have, it's a calculating spam score. As Piotr said, it's one of the main functionalities of Truecaller, that it can show you which of the numbers calling you are spammers. In general, when I started to work in Truecaller, I thought it's a very, very complicated machine learning behind this spam detection. After a few days, I found out that this algorithm is really, really simple. It's mainly based just on counting user reports. But in this case, more data means better results. You don't need to use super sophisticated algorithms, because you have such an amount of data that you can achieve better results without sophisticated algorithms. What's more, I think this data won't be that they are just too big to put them in some of the machine learning algorithms. I would like also to show you another example when data can be a little tricky. Here we have blue data points and red trend line. Who thinks that this is a good trend line, or that this red line is a good representation of this of the process generating this blue data points? Good. Here we can see that we have more data, but it still looks reasonable to think that the red line represents generation process, but there is something shady in the middle of the line, and here we can see the real process. We have more data, and we can now we can guess where the real problem is. In Truecaller, situation is very similar. In countries like India or Egypt, when we have a lot of users, the spam detection is on very, very high level, because we are receiving a lot of spam reports, so we can build good spam filters from this data. In Poland, it works relatively good, but in small countries or countries where Truecaller is not so popular, it won't be so good. What more we can do with when we are gathering such amounts of data? I would like now to show you two other cases of data usage. But first, I would like to ask a question. What do you think? Do you think if Brexit will be a big problem for people living in Great Britain? Who thinks that it will be a big problem? Please raise a hand. And who thinks it won't be a problem? This is data about calls from Great Britain. We have here 200,000 users anonymized from UK. Data is from a month before Brexit referendum. We can see here that around 10% of the calls made in Great Britain are international. For comparison, in Poland, only 2.5% of calls are international. It suggests that it can be a problem because they have a lot of international traffic. But let's see where they are calling. Here we can see split of the calls between EU and the rest of the world. International calls from EU is within EU is only 8% of total number of international calls in Great Britain. 92% is rest of the world. They are mainly calling friends and families in Commonwealth countries, the former British colonies. When we split this 8% to countries, we can see that the most popular destination is Romania, second is Poland, third is Ireland. So we can see that those are mainly immigrants and neighbors. For these people, it for sure will be a problem, but it's only a small part of a total number of calls. And at first, we here say that we have clear insights. But when we found this data, we have a second thought that maybe there is something wrong with our data. And the problem is this data set is strongly biased. Truecaller as an app is very popular in India. And this means that a lot of Indian people living in UK will also have it. And there will be relatively more Indian people in India than, for example, Polish or Romanian ones using the Truecaller app. And this is probably the reason why this slide looks like that the rest of the world calls is much, there is much more calls to the rest of the world than within EU. Another analysis you can do having calling data like Truecaller has and phonebook data is some kind of a market share analysis. We've done it for e-commerce giants in India. It was based also on a calling behavior. We assigned numbers to companies based on data we have in a global phone book. So if the contact has Amazon in name, it was assigned to Amazon. If it has Flipkart, it was assigned to Flipkart and so on. What's interesting, this data maybe are not 100% correct, but they are highly correlated with real market shares of companies in India, and they are getting a lot of public attention when published there. What will be our next steps in a Truecaller? As we have a lot of data, we still have a lot of unexplored areas. As I told you, we still use very, very simple algorithms. So we are now experimenting with some more, some less naive approaches, which maybe will give us better results. And another thing we would like to touch in Truecaller is also streaming analytics, which should help us especially in a faster spammer detection, as now it's a batch process run every day. So we will know the next day that the spammer who started calling today is a spammer, and it will also be helpful in fraud detection. And this is the end of our presentation. Do you have any questions?
This is mostly what was shown on the slide. So all events generated by Truecaller application. So each action that user of Truecaller app is doing is logged somewhere on the server. Moreover, application maintains connection with the server from time to time, just sending some health checks and so on. So this is the main data source, definitely. They have some external data sources as well, but it's tiny in comparison to the events. So this 3.5 terabyte of data is just these events generated by users. Who is calling who? Yes, so you have this kind of data.
Because if the app has to check what is because the phone book is stored server side. So when you are receiving a call or making a call, the number is sent to the server and you are getting the response. And every such event is logged.
And actually they have one more component that I haven't mentioned about. They have Cassandra clusters as well. And in Cassandra they just store this huge phone book that they have. So I guess this is like 22 billion numbers, but of course it's not unique numbers, right? So they use Cassandra for that to enable fast lookups. So when someone calls, they can be called to someone calls and number has to be identified. There is a call to the Cassandra, so it is quickly given back. You couldn't do this with Hadoop, right? Because Hadoop has this latency, so reading something from Hadoop takes time, so it's not a suitable solution for this particular use case. Any more questions? The question is, which tools are we using to track user behavior?
Maybe we should use
We have mic. I haven't heard exactly. Yeah. So just, if you can repeat your question, sorry.
Can you hear me? Okay. So you mentioned you track user behavior in the Truecaller app. So what tools do you use for that? Is it just what they select, or is there any do you use Google Analytics or anything like that to just understand how they navigate around the application?
For user interactions, it's mainly Facebook Analytics now, but we are also collecting these events in Hadoop cluster. But so let's split user interactions. It's analyzed mainly in Facebook, but this data is collected. Actions connected with core functionalities of application, like searching numbers, calling, receiving messages. Those data are collected only in Hadoop cluster internally, and for analyzing them we use mainly SQL and later Python or R. Or when it's recurring process, we are preparing, usually we are preparing a Spark job.
Okay,
And maybe
thanks.
I can add something to that. This part is not something that we are involved with. It's just on the client side mainly. But as far as I know, it's like all of the things that has to be answered in the real time. So identification of the number, for example. There is the hit to the backend system, so it's obviously logged. There is a lot of things that are being logged also when user just interacts with app. And it's not being directly sent, not results in direct hit in the backend system. So everything is just accumulated on the client side, and then from time to time, this pack of the events is sent to the backend servers.
Okay, I was just more asking in terms of user experience. So how do you know that the user knows how to use your app, basically? If they understand what the particular features are and that kind of thing.
This is a little out of scope of our team responsibilities. This is mainly made with help of Facebook Analytics.
Okay, thank you.
Okay, any more questions? Okay, so thank you very much. Maybe a few words at the end about Getindata. So we love to help companies solving big data challenges. So if it happens that you are facing some challenge that in your company that you don't know how to tackle or are unsure what are the good practices, so just give us a call. We are also recruiting quite often, so if you are very keen into big data technologies and you want to work with like-minded people, so also let us know. We can be in touch. So thank you very much for listening, and I really recommend you to use Truecaller as well. It's really a cool application. Thank you.